wonder why chronic diseases such as heart disease, diabetes, and Alzheimer's seem to rise with age? It's not just bad luck or a wear and tear. There's a deeper biological story unfolding inside every cell. Aging is a biological process, complex, dynamic, and deeply intertwined with chronic disease. Scientists now believe that aging and chronic disease share the same root causes. Think of it as a spectrum. Accelerated aging leads to earlier disease, while slower aging may delay it. Let's now explore the 10 biological mechanisms that drive both aging and chronic disease. First is genomic instability. DNA damage builds up over time. When repair systems falter, mutations sneak in, fueling cancer, heart disease, and neurodegeneration. Some of the examples are BRCA mutations, known as the breast cancer gene that increases cancer risk with age, and DNA damage markers found in Alzheimer's patients. The second mechanism is called telomere attrition. Telomeres are like caps that protect your chromosomes. They shorten with each cell division. When they're gone, cells stop dividing. Imagine telomeres as a burning candle. With each cell division, the candle burns down a bit, causing the candle to shorten over time. Shorter telomeres link to heart disease and diabetes. The next mechanism is called mitochondrial dysfunction. Mitochondria powers your cells, but aging makes them leak harmful molecules, damaging tissues and triggering disease. Just like a car engine burns fuel to move, mitochondria burns nutrients to power cellular functions. When the engine sputters, performance drops and toxic exhaust builds up, leading to mitochondrial decline that causes Parkinson's and Alzheimer's disease. The fourth mechanism is loss of proteostasis. Proteins lose their shape and function. Misfolded proteins pile up, especially in the brain. Imagine your cell as a fashion house, and proteostasis is the master tailor. It stitches proteins with precision, folds them into perfect shapes, and discards the ones that don't fit. When the tailor gets overwhelmed or sloppy, misfolded garments pile up, leading to cellular clutter and disease. This can lead to Alzheimer's and Parkinson's disease. Next is called cellular senescence. Here, senescent or aging cells stop dividing but release toxic signals. They inflame and damage nearby cells. Examples are found in arthritis and atherosclerotic plaques, or what we call fatty deposits that clog blood vessels. Next is stem cell exhaustion. Stem cells or repair cells regenerate tissues, but with age, they burn out, slowing healing and weakening organs. That's why slower wound healing is common in older adults and reduced muscle regeneration after injury. The seventh mechanism is epigenetic alterations. Epigenetic alterations are chemical modifications that change how genes are expressed without altering the DNA sequence itself. These changes accumulate over time and are now recognized as a hallmark of aging. It is linked to cancer and immune decline. Imagine that your DNA is a book filled with chapters, sentences, and instruction. Epigenetic marks are like the editor's notes. They highlight, cross out, or underline sections to guide how the book is read. The text does not change, but the interpretation does. That's how identical twins with the same DNA can look and behave differently. Next is deregulated nutrient sensing. Here, pathways like insulin and mTOR go haywire, disrupting metabolism and increasing disease risk. Insulin is like a key that unlocks cells so that blood sugar can enter and be used for energy. With age and poor lifestyle, cells stop responding to insulin. This is called insulin resistance. Sugar stays in the blood, leading to fat buildup and eventually diabetes. mTOR, or mechanistic target of rapamycin, is the growth switch in your cells. Imagine your cells have a light switch labeled grow and build. That switch is controlled by mTOR. When nutrients are abundant, like after a meal, during growth, or in times of plenty, mTOR flips the switch on. The lights blaze and your cells get to work building proteins, growing tissues, and expanding energy stores. But here's the catch. If the switch stays on all the time, the system overheats, there's no time for cleanup, no pause for repair, the bulbs burn out, the wiring frays, and the room fills with clutter. That's what happens when mTOR is chronically activated, especially with aging, overeating, or insulin resistance. Next is inflammaging. Here, low-grade inflammation creeps in with age. It's silent but destructive. Imagine your body's immune system is like a faucet that turns on when there's a problem, say an infection or injury. It releases inflammation like water to clean up the mess and help you heal. But as we age, the faucet starts leaking. A slow, constant drip of inflammation begins to flood the system. Over time, this chronic low-grade inflammation wears down your tissues and organs and repair systems. Just like water damage in a house, this can cause heart disease, arthritis, Alzheimer's, and type 2 diabetes. Last is altered intercellular communication. Cells stop talking clearly. Hormones, immune signals, and neurotransmitters misfire. This leads to insulin resistance, immune dysfunction, and cognitive decline. Also, hormonal shifts in menopause and andropause. Imagine your body as a city of smart devices. Each cell is a phone. They rely on a wireless network to send messages and to keep everything running smoothly. But with age, the signal weakens. Messages are delayed or lost. Some start sending spam, while others stop responding altogether. That's altered intercellular communication, when your cellular network becomes glitchy and the whole body suffers. Now that you know those biological mechanisms, let's now connect the dots. These biological changes lead to the most common chronic diseases in older adults. Each condition isn't just a diagnosis, it's a reflection of cellular breakdown over time. Here's the list of common diseases in aging from CDC Health eStat report from 2022 to 2023. Top 5 are hypertension, arthritis, high cholesterol, cancer, and heart disease, followed by diabetes, stroke, depression, dementia, and COPD. So what can we do to slow down the clock? While aging is inevitable, how we age is not. Lifestyle choices can slow these biological mechanisms. One is exercise. Exercising at least 30 minutes 5 days a week boosts mitochondrial health and reduces inflammation. Another is nutrition. Mediterranean diet supports proteostasis and nutrient sensing. Next is 7 to 9 hours of sleep enhances DNA repair and hormonal balance. And of course, stress management is very important in lowering the stress hormone called cortisol, which protects our telomeres. Last but not the least is social connection. Go out and talk with your family and friends often because this reduces depression and cognitive decline. These lifestyle factors are part of the American Heart Association's Life Essential 8, which has been shown to reduce biological age and risk of chronic disease, even among individuals genetically predisposed to accelerated aging. Keep in mind, aging isn't the enemy. It's a process we can understand and influence. At Your Health Knows, we decode the science to help you age wisely, not just gracefully. If this video helped you see health in a new light, give it a like, share it with someone you care about, and subscribe to Your Health Knows. Together, we're building a space where science meets clarity and wellness becomes a lifelong conversation. Thanks for watching. Stay curious, Stay well.